David Smith here with one more Flip Classroom math video in the rain. 3 tips before we start. First, you can speed up or slow down the playback if that helps you digest the content. Second, you can pause the video anytime and catch up with your notes. Lastly, you could turn on the captions and watch my words go by on the bottom of the screen. This lesson provides a little bit more practice evaluating definite integrals. So before we jump into our first example, I want to remind you of the fundamental theorem of calculus, which we did in our last lesson. So here it is. If I'm taking the integral from a to b, that's what makes it a definite integral, of f of x dx, I can rewrite that with the square brackets and the capital F, which is our notation for the antiderivative, but it means integral. So the integral from a to b of f of x dx is capital F of x from a to b. A little different notation, kind of means the same thing. Finally, to get the value of the definite integral, what we have to do is we have to do big F of b minus big F of a, and that gets us the actual value. So if we're looking at a geometric situation, what we're going to do is we're going to find the area under the curve of f of x from x equals a to x equals b. So that's the fundamental theorem of calculus, and that's underneath all of these problems. So as I walk you through this, we're going to keep referencing that theorem. Okay, problem number 1. Take the integral from -2 to 2 of 2x squared times x minus 3 dx. Now, we do have this thing called use substitution, but it's not required in our class. So I'm not going to show you how to do it that way. It can be a little complicated. This one has a much easier way to go. I am working on a video for use substitution, so I will upload that at some point in the future. So this one, we don't really have a rule for how to do that, but we can expand these 2 terms and have 2 terms where we can use the integral power rule and take our integral. So what we're going to do is we're just going to expand these 2 terms and rewrite our integral. So do that and come back. Okay. So what that gives us is the integral from -2 to 2 of 2x to the third minus 6x squared dx. Now this one, we have a nice easy integral power rule where we can take the integral of that. So I'm going to write one step ahead of time. I'm going to convert it into this notation. So what we can do is we can now write square brackets big F of x from -2 to 2. So what goes in here is going to be the integral of that expression. So pause the video, apply your integral rules, and do that math. Okay, here's the plug-in step for that, using my integration rule for kind of like my power rule, and then I simplified and reduced it on down, and I basically get x to the 4 over 2 minus 2x to the third. So that's the antiderivative, that's capital F of x, or the integral of f of x. So now, our next step is to do this one, f of b minus f of a. And that's going to get us the value of that integral. So go ahead, pause the video, do a plug-in step for that. You've got your a and your b right there, -2 and 2, and now you have your function right there. So go ahead and do that. Okay, here's my plug-in step. And I really encourage you to do a nice, careful, deliberate plug-in step so you don't mess up. There's a lot of little things that you can mess up here that'll affect your result. So I have 2 to the 4th power over 2. That's just plugging in my 2 there for x minus 2 times 2 to the 3rd power. Great. My x is positive, so I don't have to worry so much about my parentheses. But when I get over to this one, my x is -2. So I put my parentheses around the -2 to the 4th because that reminds me that I'm just doing -2 times itself 4 times. There's no negative on the outside. It's actually being raised to the power. So that's over 2 minus 2 times -2 to the 3rd. Same thing. This means that this number is going to be negative. Remember, a negative number raised to an odd power has a negative result. So you want to make sure you track that stuff. Otherwise, you're going to mess up. And then, of course, I put parentheses around both of these because this is the whole value of f of b minus the whole value of f of a. So I have to do everything in there, get a number, and then subtract everything in there. So those parentheses help keep me honest. So go ahead, take this all the way through. Your answer is going to be one number. Okay, let's see how you did. These two reduce down. 2 to the 4 over 2 is 8. 2 times 2 to the third is 16, so it's minus 16. This one ends up being the same as this one because we've got a negative number raised to an even power. The result goes positive. So again, we have 8 here. Now we're going to have a minus, and then this is going to be a negative 8. Negative 2 to the third is negative 8, times 2 is negative 16. So we have an 8 minus negative 16, which is 8 plus 16, which is 32. So now we have, which is 24. So now we have minus 8 minus 24 is minus 32. Whew! That's the process. Okay, so we started with this function. We applied the fundamental theorem of calculus to the expanded version of the function. We used the theorem to guide our steps. So I wrote that in there just to kind of help you see where we're going. We reduced down, got our single number answer. Okay, let's do a different one. So here we go. Integral from minus 1 to 0 of 2x plus 1 to the third power. So we don't have to do that expansion step we done in the last one because we actually have a rule that helps us integrate this expression in there. Oops, I left off my dx. Let's be correct there. So what I want you to do is go ahead and find that integral, that antiderivative, and write this out with that in there. Okay, so there's my straight up plug-in step using our rule. If this is not making sense to you, you do want to review that rule. So there's our plug-in step. Simplifying that on down, we get 2x plus 1 to the fourth power over 8. So that is our capital F of x, our antiderivative or our integral. So what comes next? We just figured this out. So we did that. Now we need to do capital F of b minus capital F of a. So that would be this step. And what I want you to do now is I want you to pause the video and do a plug-in step for that. Or if you're feeling bold, take the calc all the way through. Okay, so here's my plug-in step. Again, I'm using this as my model. X is right there. It's 2x plus 1 to the fourth power over 8. So I put my b, which is my ending point of my interval. I put that in for x, and I get 2 times 0 plus 1 over 4 to the fourth power all over 8. That comes down to be 1/8. And then the same thing happens here when I put negative 1 in for x. This is also going to resolve to positive 1 over 8. So I have 1/8 minus 1/8. So my answer is just 0. And so this tells me something about the graph. The graph has to be equally above and equally below the x-axis over this interval from minus 1 to 0. And I'm thinking of a cubic function that would do that based on this, based on my cubic, that I could see how that would happen. But we know if the integral over a range, if the definite integral is 0, then the area has to be 0. So you have to have a positive and a negative so they cancel out and go to 0. Check this one out. Now we have the integral from minus 5/4 to 1 of the square root of 4x plus 5. Now, this is getting a little bit more complicated. We're going to have to do a bunch of different conniptions to get there, but we're going to make it happen. So first step, we need to put this in a form where we can apply one of our integral rules. So go ahead and pause the video. It's just a one step, but I want you to rewrite this integral so that the integrand is in that correct form. Okay, so I remembered that the square root is just a 1/2 power, so I rewrote this with the part under the root as 4x plus 5, that's the part on the root, all raised to the 1/2 power. So now I can use my integration rule to catch the integral of this so that I can find out what this is. F of x from minus 5/4 to 1. So go ahead, pause the video, and do that rule. And you're going to have a little bit of fraction-y stuff to deal with to get it down and simplified, but you do want to simplify it pretty far because then you're going to have to use it. You're going to have to plug these values into your integral to get your values. So go ahead, pause the video, let's see what you get. Okay, so here's how that works. Here's my straight up plug-in step. I just did my a times my n plus 1. Here's my function, the inside part of my function raised to the a to the n plus 1 power. Simplify that on down. This little fraction becomes 1/6. That's 3/2. The 3/2 power is the same as the square root of the thing to the third power. And then I just put that over 6 instead of multiplied by 1/6. So there's my simplified integral. Now what I need to do is find out what f of little b minus f of little a is. So now do a plug-in step and take that calculation on home. Okay, check it out. This gave us a pretty interesting result. So here's my plug-in step. I'm using my integrated function, my integral, and I'm putting in my b, which is 1, in for x, in all that. So there's my plug-in step. Let's stick with that one. So now I'm just going to evaluate that on down. This becomes 9 cubed. Take the square root of that and then divide through by 6. That ends up being 4.5, so a pretty clean number. Now this one's kind of interesting because if I put 5/4 in here, minus 5/4 times 4, this is negative 5. Plus 5 is 0. So suddenly we have 0 inside here. Cubed is still 0, square root is still 0, so we have 0 over 6, which is not a problem. It's not a divide by 0, it's just 0. So our integral is going to be 4.5 minus 0, or just simply 4.5. Oh boy, you might have thought that either a natural log or an E-type integral was coming, and you were right. So this thing looks pretty complex, but we're going to do some stuff it's going to make it way, way easier to deal with. Okay, so right now we have the integral from 1 to 3 of e to the 4x plus e to the 2x all over e to the 2x dx. So before we start integrating, we want to simplify the integrand. And there's a bunch of things we can do. So check this one out. These are both over one denominator, so we can split them apart. And the second one is going to be e to the 2x over e to the 2x, which will just be 1. So watch how this works. We're going to get e to the 4x over e to the 2x plus e to the 2x over e to the 2x. That's what this is. We just broke it out into two fractions. This becomes 1. So now we have e to the 4x over e to the 2x plus 1. That's much more simple. So what can we do here? How can we simplify this on down? Here's one thing to recognize. We could rewrite this one as e to the 2x times e to the 2x over e to the 2x, right? That's what that is, plus 1. So now, I can bring this one up and it becomes a minus 2x. So that's going to cancel this one out. So what we wind up with is e to the 2x plus 1. Now that is a much more simple integrand. We can integrate that one all day long with just the one or the two rules that we have. So let's go ahead and do that. Pause the video and go ahead and take the integral of this, but do it of that because that's equivalent. Okay, so here's what I get with that. I'm going to integrate each piece. This is just two terms. So I'm going to integrate e to the 2x, which gives me 1/2 e to the 2x. If you look up your integration rule for e to the something x plus something, you're going to see this is how you do that one. And then, of course, 1 just becomes x. So I'm going to simplify this down a little bit. I have e to the 2x over 2 plus x. So now what you need to do is do your big F of b, which for us is 3 minus our big F of 1. So go ahead and do a plug-in step and crunch that one down. Remember, we're in paper 1 land, so no calculator, so you're going to have an E in your answer. Okay, just about done with this video. Woohoo! Here's my plug-in step. I'm just doing my F of b, which is 3, so I just put my 3 in for x. In both of these terms, that's this section, keeping track with my brackets around both terms, subtracting, putting in 1 for x in these two terms. There's the plug-in. So I wind up with e to the 6th over 2 minus e squared over 2 plus 2. This is a perfectly good answer. I tend to like it if you can put everything over one denominator. So I did that. So it's e to the 6th minus e squared plus 4 all over 2. Either one is equivalent. Either one is just fine. Thanks for watching. Just before you go, make sure to write down any questions that you have so that you can bring them to our next class and get them answered. Also, remember that you can watch the video again if you want to deepen your understanding. Finally, if you enjoyed the video, please click like or subscribe.